Good day, viewers all over the world. You are welcome to Toydel online class. Today we want to look at, I want to consider the first method of resolution when we want to resolve a compound fraction to sum of its partial fraction. Like this example that we have on the board. We are given 7x plus 19 all over x plus 1 into bracket x plus 5. So we want to resolve this to sum of its partial fraction. Then, before we go to types of partial fraction, I just want us to consider the two methods of resolution, cover-up method and comparative coefficient. So today, I want to concentrate on cover-up method. So what do we do here? If you want to resolve any compound fraction to sum of its partial fraction, you consider the denominator. In this case now, we have two linear factors. That simply means that when we have two linear factors, we just say a all over x plus 1, then plus b all over x plus 2, x plus 5, as we have it there. So this is how we will resolve this, because there are two linear factors here. If we have repeated factors, what do we do? By the time we get to types of partial fraction, I'm going to explain better on that. Then the next step is that we are going to multiply both sides by the denominator of this left hand side. That is, if I use x plus 1 into bracket x plus 5 to multiply this side, if I have x plus 1 into bracket x plus 5 to multiply this side, this will cancel everything here, and at the end of the day I'll be left with 7x plus 19. Then from there, now if I use these two, the denominator, to multiply the first concept that I have here, this will take care of this. I'll be left with a into bracket s plus 5. I'll do the same thing here. If I use s plus 1 into bracket s plus 5 to multiply b over s plus 5, this will take care of this. I will left with this. I will have b into bracket s plus 1. So at this point now, we have resolved everything to a straight line. So once we have resolved it to a straight line, so how do we get the value of the unknown, a and b? That's what we want to do. But I said we want to use the first method, cover-up method. What do we do under cover-up method? This is what you do. Check x here. What do we have here? We have x plus 5. If I say x, if I put x to be equal to minus 5, then minus 5 plus 5, will it not be 0? That will be 0. Then if once my x is equal to minus 5 here, everything here will vanish. Then we'll be able to get the value of v. If I come back to this point and now say let x equal to minus 1. If x is equal to minus 1 here, minus 1 plus 1, everything will vanish here. I'll come back and get the value of a. That is this what this is what I'm trying to say. Under cover-up method, we think of the value that we can use to make x to be equal to 0. We say put x is equal to minus 5. If x is equal to minus 5 on this straight line, then I'm going to have 7 into bracket 5. S is now 5, is minus 5 plus 19 is equal to a into bracket minus 5 plus 5 plus b into bracket minus 5 plus 1. That's what we are going to get. So here we have minus 35 plus 19 to be equal to minus 5 plus 5 is 0. So everything here will vanish. We are going to get 0 here. Then at the end of the day, we will be left with minus 4b here. We'll be left with minus 4b here. Minus 35 plus 19, that's minus 16, is equal to minus 4b. Then we divide both sides by minus 4b. This will cancel this. Minus will cancel minus. Therefore, b will be equal to 4. So we have gotten the value of v. When we put s to be equal to minus, when we put s to be equal to minus 1, then we go ahead. Also, we also do for, we have gotten the value of b to be equal to 4. Then we also say put x is equal to minus 1 because we have x plus 1 here. Then if we do that, we have 7 into bracket minus 1 plus 19 to be equal to a into bracket minus 1 plus 5, then plus b into bracket minus 1 plus 1. Minus 1 plus 1 is 0, so everything here will be 0. We'll be able to get the value of a. The implication is that when I cover this up, I get the value of a. When I cover a up, I get the value of b. That's why the method of resolution is called cover-up method. So if I do that here, I'm going to get minus 7 plus 19 to be equal to 4a. This is going to give me 12 is equal to 4a. Divide both sides by 4. So a is equal to 3. So we have been able to get the value of the two unknown, a and b. Then finally, since we have done that, using the method of cover-up simply means put the value of x here now, x plus 1. If I put x to minus 1, this will cancel out. That's the meaning of cover-up method. Once you cancel one out, you get the second one. You see, it's as if you cover this, you're going to get the value for the first unknown. If you cover this, you get value for the second unknown. That is how to apply cover-up method. So we have gotten the value of the two unknown, a and b. A now is equal to 3. So what is now the partial fraction of this concept? We now say Finally, this compound fraction now, the sum of its partial fraction will now be A is 3. It will be 3 all over x plus 1 plus B is 4. 4 all over x plus 5. We have been able to resolve this compound fraction to sum of its partial fraction. If I find the LCM, do the necessary thing, I'm going to get this compound fraction back. That is how to use the first method, which is called the method of cover-up method. Thank you.